All right, we are live again. Day one, CAMX 2025. I have Gary Owen. He is the CEO of Lineat Composites Limited. Gary, thanks for stopping by.
No problem, Jonathan. Thanks
Yeah.
very much for having me.
Yeah. So, just to give you a little background, they've commercialized the novel alignment of waste carbon fibers, resulting in a discontinuous unidirectional material. This material can be reintroduced into supply chains ahead of current commercial available recycled materials. Their material is aligned along the warp or zero axis, so offers offers multiple manufacturing opportunities, and they can use both industrial and post-consumer waste carbon fiber once it has been reclaimed and any resin removed. So yeah, glad to have you joining me.
Thanks very much.
Tell us a little bit about yourself before we get started talking about the technology.
Yeah, I'll skip over the good bits, but no. So
Yeah, give us the good
my
stuff.
background is mainly in the textile industry. So
Yeah.
over 25 years, textile, flexible composites. Worked for a large German textile organization, developing sailcloth
Okay.
of all things for yachts.
Okay.
So from small dinghies up to super yachts, Olympics.
Yeah.
America's Cup, all those sorts of things. So
That's great.
Thoroughly involved with that. I'm a yachter.
Yeah,
So that's really
Where is
exciting.
some of the best locations for yourself when it comes to
Anywhere
yachting?
where there's wind. I don't care whether it's sunny or snowing.
Yeah.
As long as there's wind,
yeah,
I'm happy.
fantastic. All right, well, tell us a little bit about the this new material.
Yeah, when you say new, it was first developed back in the 80s.
Okay.
So the primary inventor, Professor Kevin Potter of Bristol University, when he worked in military defense back in the 80s, was looking at how to conform virgin UD to
Sure.
complex shapes.
Right.
You know, it's inherently very stiff. So he started by breaking fibers and putting short fibers together. Fast on 30 years, and it was one of his postgrad students, Dr. Hannah Yu, who got together with Kevin and developed this process, which in the university is quite well known globally under the Hyperdiff name, which was basically an advanced paper making process. So we take chopped waste carbon fibers between 3 and 10 millimeters long. We disperse those in water, and then we align them through our patented alignment process. We extract the water, and we have a discontinuous UD material.
Any challenges in that?
Lots of challenges. It's funny you should say that because we have a patented process. So
Yeah.
occasionally we do get people asking how we overcome the problems
Sure.
that
Yeah.
we have. And fortunately, that's not patented. That's know-how.
Yeah.
It's like anything. So it's similar to a wet laid process that non-wovens take. So they mix fibers in water, but they're randomly orientated.
Okay.
We don't want that random distribution. We want a UD
Right.
material. So any fibers that are longer than 10 mil that can come entangled in the manifold process, that does cause us problems. So we've been working on this at the university. It was developed over probably about 8-9 years.
Okay.
And we've commercialized that back in 2020. The company was formed.
Okay.
It's a spin out of Bristol University.
So your fibers, you said again, shorter, between 4 and 10 millimeters.
Between 4 and 10 millimeter fibers. And
Okay.
the process itself was developed actually to combine different fibers, so glass and carbon
Sure.
fiber,
Yeah.
and try and exhibit different properties, ductile properties of glass versus the stiffness of carbon fiber.
What are some some opportunities this opens up for you all?
So our kind of default weight of our material is extremely light. So
Yeah.
we can make 15 grams square meter material.
Okay.
So, and that is easy for us to make, whereas most production processes, that's difficult to do. So it lends itself to very lightweight components, so UAVs, drones, but also electronics. And because of its discontinuous properties, it can conform to much more complex shapes than virgin carbon fiber can.
So what industries maybe you could identify that do you see adopting this first?
Well, kind of, we look at all the different sectors and we identify the low-hanging fruit. So
Yeah.
the low-hanging fruit, like most
Obviously,
people,
yeah, that's where you want to target in on.
is the sports market.
Okay.
That's a global market.
Sure.
So we've worked with people like Wilson and Head and Scott, bike companies, racket companies, using our material.
Yeah.
Which has been good. But also, initially, we were kind of a bit reticent at going after things like the aerospace sector because we knew the certification is such a lengthy process. But we've had that turn around, and the aerospace companies are actually approaching us and say, we want to work with you.
Really?
We generate a lot of waste.
Yeah.
Boeing, Airbus, those people
Absolutely.
generate a lot of waste.
Yeah. Well, that's a recurring theme is sustainability, right? I mean, we're looking at what to do with these materials after life, right? How do we reincorporate them? So it's always great to see that companies like yourself out there, what you're doing, and reintroducing a lot of this back into technology that we can use.
Yeah, no, definitely.
And into markets that use sporting goods, aerospace, you name it. So, Gary, thanks for coming by.
No problem. Thanks
Yeah,
very much.
good to see you.
Cheers.
Cheers.